Dear students, in this class we are going to discuss about the capacitance of a spherical capacitor. We know well that the capacitance of a conductor is defined as the amount of charge Q on the conductor to increase the potential on the conductor. In the last class we have seen these two parallel plates. It is charged plus Q, it is neutral. When it brought near to this plate, the charges are induced in the plates B. The positive charge in the A created minus and plus induced the minus charges here and positive charges here. The positive charges are earthed, so it is the conductor. So its capacitance of the conductor is given by the capacitance C is equal to charge Q by the potential developed in this V. So today we discuss about the capacitance of a spherical capacitor. It is a spherical capacitor. It has two concentric spheres. This is this one and it is the outer sphere. Now we discuss the capacitance of a spherical capacitor. The capacity of this spherical capacitor to hold a voltage. Now drive the expression for the capacitance of a spherical capacitor. See here it is a spherical capacitor. It has two concentric metal spheres. It is the metal sphere A. It is the outer metal sphere B. So the metal sphere it is A. It is another metal sphere B. Its radius is the inner metal sphere radius is A. The outer metal sphere radius is B. There is an air medium between these two spheres space. It is a free space. In this free space, the air is present. The permittivity epsilon naught, the permittivity of the air is epsilon naught. The outer sphere B is earthed. This outer sphere is earthed. Here also it is earthed. A charge plus Q, a charge plus Q is given to the inner sphere A. The charge is given here, A plus Q is given at A, so that A minus Q, its opposite charge, minus Q is induced and a plus charge, positive charge also is induced, but the outer sphere B is earthed. Due to this reason, the positive charges are earthed, so the only negative charges are present in the surface. See here, the negative charges are present at the surface in the outer sphere. The positive charges plus Q are present in the surface of the inner sphere. Now let's consider a point P. Now we are taking a point P in this air medium, taking a point P at a distance R from center. It is the center. It is the point P. So the distance between O and P is R. A point is taken in this space. It is point P. Now the electric field due to these charges, the electric field at this point P due to these charges is given by the formula E is equal to 1 by 4 pi epsilon naught Q by R square into R vector. It is R vector is a unit vector along the direction. It indicates the direction of the point and field. What is epsilon naught? 4 pi is the space, but epsilon naught is the permittivity of a free space or permittivity of the air. So the air is present in the free space. Sometimes a dielectric material also present in the free space. So the epsilon is depends upon the material that present in this space. The material present in this sphere. In our study, the air is present. The permittivity of the air is epsilon naught. What is permittivity? It is the ability of the material like air or dielectric material to store the electrical potential energy, to store the electrical potential energy under the influence of electric field, under the influence of electric field. If you apply a charges or a electric field, this material holds, the different material holds differently. So the ability of the material to store the electrical potential energy is called permittivity, or the permission. It permits to store the charges. So the potential difference between the sphere A and B is given by, it is the potential difference or the voltage capital B is equal to minus integral a b to a e dot dl. So when the dl is a differential vector displacement along a path from a radius a to p. See here. So the potential difference between sphere A and B is given by this, where dl is a differential vector displacement along a path from the radius a to p. This distance is from 0 to here is a, from this radius a to the point p. This is dl. It is a differential vector from here to here. So the E into dl, the electric field into this dl equal to here, E into dl cos theta into 180 degree. You know cos 180 is equal to minus 1. So this E dl, the E capital dl is converted into minus E dot dl. Further, on moving a distance dl along this direction of motion, the r value, see here is decreasing. So the dl is taken as dl equal to minus dr. So here, suppose we are moving towards this. So E is E dot equal to, so dl minus dr equal to E dl is equal to positive E dot dr. We know well the equation E. Now you substitute the value of E in the equation. This, so E is 1 by 4 by epsilon into q by r square into r. On substituting this value, we get this equation. We are integrating. On integrating this, we get minus 1 by r. This 1 by r square minus 1 by r. We are substituting the upper term, minus into minus, which is a plus. So upper term is 1 by a minus lower term 1 by b. On cross multiplication, b minus a by ab. And then we know that now we got the value of potential, the potential difference, the voltage. V is equal to Q by 4 by epsilon naught into B minus A by AB. Q is the charge, 4 by is the space, epsilon naught is the permittivity of the air medium. You know what is B? B is the radius of the outer spherical conductor. A is the radius of the inner shell. So from this we know that the capacitance of the spherical capacitor already we have solved. C is equal to Q by V. The capacitance is equal to charge by potential. So we know that charge Q. So now we have applied positive charge plus Q, and we got the potential difference value like this. So Q gets cancelled. The 4 by epsilon naught AB is gone to the upper side. So on solving this, we get the equation like this: 1 minus 4 pi epsilon naught 1 minus 1 by a minus 1 by b. Now the point P is taken to infinity. See here, the point P is taken to infinity. When we are taking to infinity, it goes beyond the B. So it is the limit of this capacitor. When we take this point above from this limit, so this B becomes infinity. So see here, so the point B is taken to infinity, then why B becomes 0 here? Here 1 by B, substituting the value of B as infinity, so 1 by infinity is taken as 0. Then 1 by infinity is taken as 0, so these terms vanished. So C is equal to 1 by 4 by A. So as it is vanished, the A's is go to upper side numerator. So C is equal to 4 pi epsilon naught A. So this is the final equation. This is the capacitance of a isolated spherical capacitor of radius A and B.